So let's look at a little bit about how these things come about. So what we are showing here is typical boreal winter quantities of sea surface temperature, total column water vapor and precipitation, and for the boreal summer the same quantities. And here it's showing zonal mean distribution of temperature, water vapor, and rainfall. You can see that when the sun is to the south in the boreal winter, the warmest temperatures in the tropics are also shifted to the south, and they shift to the north and look much more distributed in the boreal summer because again of this asymmetry in the land and the heat contents and the associated dynamics. But you can see that there are these bands of very warm temperature with colder temperatures on the equator. So temperature is not uniformly warm on the equator. Okay, so that's the first thing to notice, and that the entire warm water volume moves back and forth. And there are special regions like the Gulf of Mexico which remain very warm as well. But you can see this band of warm temperatures here where there is also very high total column water vapor, because that's where the convergence and the rising motion is happening that we saw in the Hadley cell. So the Hadley cell itself is going to move back and forth with the sun. But you can see that it's stronger here when the sun is in that hemisphere and weaker here when the sun is in the other hemisphere. So you can see in some sense the ITCZ is moved here and stronger and weaker here, and moved here and stronger and weaker over here. But the Indian region is complicated because again the land is so close to the tropics and the ITCZ gets split and you have the monsoon circulation here and so on. The other big thing to notice is that the water vapor is converging and it's getting concentrated in these regions. The dynamics of why that happens is very complicated, but the evaporation is happening over large regions, and those trade winds and the westerlies and easterlies and so on are converging that moisture into those regions where rainfall is very high as well. So you can see that rainfall is very high here in the ITCZ, which is down here, and weaker over here, and also over here with rainfall over the Amazonia and other rainforest regions. And you can see in the summer there is monsoon rainfall over here. ITCZ, intertropical convergence zone, is strong all the way across here and much weaker down here. And you also have these mid-latitude precipitation where the Ferrel cell and the polar cell meet and there is a convergence. So even though there is no warm water there, the dynamically forced convergence is able to lift the moisture and create storms and rainfall over there. Okay, the actual dynamics is quite complicated because the angular momentum going from there to there becomes unstable, so you have storms rather than steady rain like here. So the characteristics of the rainfall are very different in the tropics and in high latitudes. But these scale selections are critical, and obviously as we saw in the Köppen distribution of vegetation, rainfall determines all those things. And broadly speaking, the climate zones are defined as polar and subpolar zone, temperate zones down here, subtropical zones in these yellow colors, and the tropical zones. So you can see where the rainforests are and where the warm temperatures are, but also where the Hadley cell sinks and creates the desert. So there are deserts here. Because of the monsoon, the deserts move northward, and India actually gets the monsoon instead of being largely a desert. The desert is only in the northwestern part. This is the precipitation map again, and snow as well. And you can see that once you add the complications of the land distribution and the mountains, rainforests, Himalayas, Burmese mountains, and so on, the rainfall distribution becomes quite complicated or complex, and the distribution goes from above 80 millimeters. This unit cannot be read here, but obviously there are high rain regions, and you can also see the difference between the west coast here and the east coast, because there are cold temperatures here and drier regions, whereas continental weather and more rainy region here. Of course, the Gulf of Mexico and the tropical nature of the southeastern US, and so on. Okay. So these are important things which determine, again, the vegetation types: tropical forests, savannas, deserts, high mountain ice, chaparral, temperate grasslands, and so on and so forth. But this is what we meant by Köppen's classification, which he did without having all these temperature and rainfall data. He basically looked at vegetation and imagined that precipitation and temperature must have something to do with those. So when we come back, we will look at more the Earth system concept and keep adding other details to this rather brief introduction to the energy balance and atmospheric circulation. But in my other courses on the YouTube channel, I have many more details, especially if you're a dynamics person and wants to learn about the equations of motion, their derivation, and setting up of the Hadley cell, and so on. Those are available in the Ocean Atmosphere Dynamics course, and some simpler versions are also available in the Oceanography course and the Bending the Curve course as well. Okay, for this purpose we have to move on to other details like terrestrial ecosystems, carbon cycle, paleoclimate, and so on. So we will leave this at this introductory level. Okay.